Hello there, I'm Mr. Math Guy, and today we're going to be taking a look at a 10-minute video on inscribed angles. Just a quick review before we get into inscribed angles. We have an angle here in this circle, and there's a special name for this type of angle, where the vertex is the center of a circle and whose rays are made up of radii. And its name is it's a central angle. Now, the thing about central angles is they are equal to their intercepted arc. So the arc that's formed from these two endpoints, from here all the way to there, that arc, let's say this angle is 85 degrees, then the arc is also 85 degrees. Remember, the distance around a circle is 360. So from here to here, this arc that is formed from these two endpoints on the circle is 85 degrees. It's equal to its central angle. Now, an inscribed angle, its vertex is located on the circle. Okay, so you can see here I have another angle, the red angle, and its rays, all right, they're just segments. They stop on the circle, but they are chords. So you have this was a chord, and that one is a chord, and the vertex right here is on the circle. This kind of angle is what we're looking at here, and it is called an inscribed angle. And it also has some unique properties, kind of like the central angle did. So let's take a look at some of these ideas with the inscribed angles. Alright, so what we have here is I have drawn what we call the intercepted arc of the inscribed angle. It is the arc that is formed from the two endpoints of the segments. Alright, and notice they would be in the interior of the angle, not the exterior. Now, one of the things that we learn about inscribed angles is actually a theorem, is that it's the measure of its intercepted arc is equal to half of the angle. So, for example, if the inscribed angle is 80 degrees, that is 1/2 of its intercepted arc. So the intercepted arc up here is twice as big. So the intercepted arc would be 160 degrees. So the theorem is the measure of an inscribed angle is equal to 1/2 the measure of its intercepted arc. Or another way of saying it is the measure of its intercepted arc is going to be twice the measure of the inscribed angle. Alright, so let's take a look at a few more theorems here. The first one is if two inscribed angles intersect congruent arcs, then the angles are congruent. Now, I've drawn down here not just they're intersecting congruent arcs, but they're intersecting the same arc. So it works both ways, though. They are both intersecting from here all the way to there. So let's say that this is 100 degrees. If that intersected arc is 100 degrees, then the angles are 1/2 of those. So then this angle would be 50 degrees, and this angle here would also be 50 degrees. Now, it doesn't just have to be the same congruent arc. It could be any arc that are congruent. So if one was 100 and a completely different arc was 100 degrees, then both angles would be congruent. They'd both be 50. So that's the first theorem. The next theorem we have is an angle inscribed in a semicircle is a right angle. So a semicircle is half a circle. So we got, going across here, we got a diameter. Sorry, it's not completely straight, but a diameter there. Now, if we have an inscribed angle whose intercepted arc is half the circle, or what forms right there to there, then we know that this angle is going to be, bam, a right angle, because we know its intercepted arc from here all the way around the circle from here to here is its intercepted arc, and that is 180 degrees, and the intercepted arc is half of that, so this must be a 90-degree angle. So there's another theorem. And this last theorem that I have here says the opposite angles of an inscribed quadrilateral are supplementary. So we have this quadrilateral that I have inscribed in the circle, opposite angles. So for example, angle 1 here and angle 2, they're opposite, they're not adjacent to each other. These two angles are going to be supplementary to each other. That means they're going to add to give you 180 degrees. And then, for example, angle 3 and 4, those are opposite angles, so those would be supplementary. Those would add to give you 180 degrees. Let's take a look at a few examples here. We have here a circle O, and we have a bunch of different chords going on here, a few angles that are formed. And this first one, we say the measure of angle 1 is 40. So up here at angle D, that is 40 degrees. What is the measure of arc AB? Well, if you take a look at arc AB runs from here to here. And if you take a real close look, angle 1, its chords form that intercepted arc. So if angle 1 is 40, according to the first theorem that we looked at, then the angle is going to be half of its intercepted arc, which means that the measure of AB must be 80 degrees. Let's take a look at another example. We have the measure of arc AB, that same arc, is equal to 130 degrees. What is the measure of angle number 2? Well, if you take a look at angle 2, its intercepted arc is arc AB. So if arc AB is 130, then the measure of the angle is equal to 1/2 of that. So then our angle is 65 degrees. Our next example, we have the measure of arc CBD. A good thing to do is probably try to draw and locate where that's at. So let me erase this one right here, and let's try to draw where arc CBD is. So you start with C, and you go all the way from here. You're going all the way CB. You got to go in the order CBD. All right? So that's the arc we're talking about. Sorry, it's not a perfect there on the circle, but just imagine it's that arc. Now, it says the measure of arc, or excuse me, I did the wrong thing. It's the measure of the angle. My fault. Angle of CBD. So angle CBD right here. CBD. So we're looking at basically angle 4. All right? So angle 4, then, its intercepted arc is this part that I didn't shade in. Sorry about that. Its intercepted arc is CD. Now, it says that this angle right here is 40 degrees. What we want to try to find is the measure of arc CAD. So we're trying to find the measure of arc CAD, which is from here to there. That's that part that I drew at first. Sorry about that. It's this part. So I'm trying to find the purple part. All right, so let's do a little bit of work here. If we know that the measure of that angle is 40 degrees, then we know that this is twice that, so this is 80. Now, that's not what we're asked to find. However, we do know that the whole circle is 360. So 360 then, minus the 80 degrees, because that's what the rest of it's going to be, that is equal to 280. So arc CAD then is 280 degrees. So the main idea here in this section or in this video is that if you have an inscribed angle, all right, so got this circle, we have an inscribed angle. Whatever the inscribed angle is, its intercepted arc is going to be twice that. Or another way of saying it, the intercepted arc and its relation to its angle, the intercepted arc is twice that, or the angle is half the intercepted arc. Either way you want to say it. So just a quick review, if this is 10 degrees, then the intercepted arc would be 20 degrees. Thank you for watching. God bless.